Hello, welcome to the second part of Istio Deep Dive. My name is Andres, and today I will be showing you how the Istio configuration and the policies get translated into Envoy configuration. This video assumes that you have at least a basic understanding of how Istio works. If you want to start from the beginning of the series, you can find a link below to the first video. So the first thing we're going to do today, we're going to take a look at how Istio implements the data plane. We're going to take a look at some of the Envoy configuration elements and how we go from the Istio configuration to the Envoy configuration. Okay, the first thing we're going to do is we're going to take a quick look at how the data plane is actually implemented inside our pods. So let's take a look at what pods I have running. I have 3 pods. Each one of those pods has 2 containers. One is the actual application container, and the other one is the sidecar container. I could use any of this, but I'm going to focus on the sleep pod. So the first thing I'm going to do is I'm going to log into the node that is running my cluster. I am using Minikube, so I use the Minikube SSH command. I need to become root to be able to do this. Now, I'm going to try to find the process ID, the Linux process ID, for one of the containers for my sleep pod. So I can use docker and here I have different containers, the different containers that are running for this particular pod. So I could use any of them, but I'm going to use this one. All right, so now let's try to map from a Docker container to an actual Linux process ID. So I can do that using docker top. And let's use this process ID. So I can use ns-enter, which is namespace enter, to be able to go into the networking namespace for this pod. Again, remember, all of the containers inside a single pod are going to share one network namespace. Okay, so I can use the process ID to get inside my network namespace, and then I can examine the IP tables configuration for this particular namespace. So what is happening here? Basically, we have 2 sets of rules, one for inbound traffic, where we have some exceptions of traffic that is not going to be sent to the proxy. These are the exceptions, which we just return and keep processing. But everything else is sent to Istio int redirect, which we redirect to port 15006. For the output traffic, we do something similar. We have some exceptions here, and then everything that doesn't match one of those exceptions, we redirect to Istio redirect, and then that traffic gets sent to port 15001. So basically, Istio is configuring the IP tables of each and every pod that is instrumented with the sidecar to be able to send the outbound traffic through the proxy, and also to basically route all of the incoming traffic through the proxy. And then inside of the proxy, we can do all of the transformations, all of the configuration that Istio provides for us. Okay, now let's take a look at how the Istio components are actually mapped into Envoy configurations. So let's take a quick look at the pods that I have deployed. I have Mach 1 and Mach 2. they are the same application, however, they are slightly different versions. And they're actually mapped through the same service. I have a Kubernetes service that has a selector that matches Mach 1 or Mach 2. So basically what that means is that when I try to hit the Kubernetes service, and I'm doing this through my sleep pod, I am going to be hitting randomly either Mach 1 or Mach 2. So, you know, about half and half of the time. This is how Kubernetes services normally behave. It's basically just probabilistically, I'm going to hit any one of the pods that match the particular selector for the service. And in this case, the service that I'm hitting is called Mach. My Mach application also has another endpoint, which is /version, which again also returns 1 or 2, depending on which one I'm hitting. So I have two different endpoints. I have the root endpoint, which returns OK1 or OK2, and I have the /version endpoint, which returns 1 or 2, depending on which one I'm hitting. So we have this service, which is probably not what we want. We want something a little bit more deterministic, and Istio can help add some routing on top of the regular Kubernetes service. For example, we can ensure that when we're hitting one particular endpoint, we are hitting a specific subset of the pods. And we have that defined inside of a virtual service. So what do we have here? We have an Istio component, which is a virtual service, has a name, just like any Kubernetes resource. We have a host. This host matches the Kubernetes service that I was hitting using my sleep pod. And in here, we have two different routes. We have a route that is going to match anything under version. And we're going to send that to the actual Kubernetes service, but we have defined a subset. And we're going to take a look at subsets in a second. We have a second HTTP route, which matches everything under / except for version, because that one has already been defined, and it goes again to the same service but subset 1. So where do we define the subsets? We define the subsets as part of a destination rule. The destination rule matches the host, and it allows us to define the subsets based on a set of labels. So the labels that we have here is version 1, and we have version 2. And the two pods that I have match these particular labels. The first pod has label version 1, the second pod has label version 2. Okay, now that we've taken a look at the virtual service and the destination rule, let's apply our routing. Okay, so the virtual service was created, the destination rule was created. Now let's run wget again from inside the mesh through my sleep pod, which is part of the mesh because it has the sidecar container. And when I hit version, I am always going to be hitting Mach 2. I'm always going to be hitting the particular subset that is mapped to version 2. If you remember, when I first was doing that, we were getting 1 and 2 roughly 50% of the time each one. If I hit the root of my service, I am going to get 1 consistently. This is another subset, and for this particular path, we're sending everything to subset v1. Okay, great. So with this, we've been able to get something a little bit more deterministic. Now, let's examine the Envoy routes. All right, so let's take a look at the proxy configuration. We're going to look at the route, and we want to see the route of the sleep pod. Okay, so we have quite a few here. Let's filter things a little bit more narrowly, and we're actually only interested in hitting the mock service. So what do we see here? We actually have 2 routes. We have the one that matches /version star. It's defined by the virtual service that we just applied. And we also have another route that matches /everything, and it also has been defined by this particular virtual service. And we can take a look at this in a little bit more detail. For example, let's dump the config using the JSON format, and we're going to dump this into a file called vs, which is going to have the JSON configuration for the routes after we have applied the virtual service. Okay, great. Now, what we can do now is I can actually compare this with the previous configuration before I applied the virtual service. I took another dump of the configuration before applying it, and I have that configuration stored in a file called original. And let's do a diff comparing this one to the configuration that we got with the virtual service. Okay, great. What do we see here? The first thing that we see here is that before we had a route called default. Now we have a route called version route. Again, the route that we define as part of the virtual service. Before we had the default route that would match /star, basically everything. But now we have this constraint to only version. In terms of the cluster, the upstream cluster that we're going to use to service these requests, you can see that the name of the cluster is very similar, except that now we have an extra parameter here, v2, which matches the subset that we define in our virtual service. So we have some extra configuration here. We have some extra configuration here that has been defined as part of the route. And we also have yet another route. Remember, we defined 2 different routes. The second route is matching everything from the root except for version, because that one takes precedence because it was defined before. And again, it is going to a cluster that includes a parameter for the subset. Okay, so with this said, we can take a look at the actual clusters. If you see here, we see the 2 clusters that have the subset defined. It's an extra qualifier which configures Envoy to send the traffic to the right endpoint depending on which route we are hitting, which leads us to the endpoints. In here, we're going to see the endpoints, which are the individual IP addresses of the services that are going to actually fulfill this request. And we can see the IPs of the endpoints that belong to the V1 cluster. And there should be one for the, okay, here it is. This is the one for the V2 cluster. All right, so adding a virtual service and a destination rule has altered the mesh configuration significantly. It has added routes, which are matched based on the path. It has added clusters, basically one cluster per subset as defined in the destination rule. And it has added the endpoints for the new cluster. In more specific terms, the virtual service altered the route, and the destination rule added the clusters and the endpoints corresponding to those clusters. Now, at this point, it is worth noting that the configuration that we're looking at was applied to all of the proxies in the mesh. Nowhere in the configuration that I show you for the virtual service or for the destination rule did we mention the sleep pod that we use to query the service. So basically, it's part of the concept of the mesh, because we want to propagate that configuration to all of the nodes, so that all of the nodes, to all of the pods, so that all of the pods can make their own routing decisions. But sometimes we want to limit that a little bit. We don't want to propagate all of the configuration to all of the pods. A very good example is gateways. Now, a gateway is normally a way in which we can allow users that are external to the mesh to have a well-defined entry point into the mesh. Now, I actually have a gateway configuration that I'm going to deploy. Let's take a quick look at it. And we're basically going to configure this gateway using a slightly different virtual service. Now, this looks very similar to the virtual service we were looking at before, but there's a few key differences. The first one is the host. In the previous virtual service configuration, the host name was the Kubernetes service name. In here, it is actually an external host name. This is the host name that the gateway is going to listen on. The second part is that we are listing the gateway in particular that we want this configuration to apply to. When we do things like this, we are telling Istio only propagate this configuration to this particular sidecar. If we omit the gateways field, it defaults to a gateway called mesh, which basically propagates the configuration to all of the sidecars in the mesh. Okay, so after I applied the routing for my gateway, I am going to be able to access my Kubernetes service from outside. So in this case, I'm using curl directly from my computer. I am not going through the sleep pod. I am accessing this as if I were any user outside of the mesh. Okay, so what is happening here is that when I hit the root URL, I should always be hitting Mach1. And if I were to hit the version endpoint, I should always be getting 2. So again, we have the routing. However, this time in particular, the routing will only be applied to the gateway itself. Okay, so let's take a look at the configuration, at the status of the proxies. And in this particular case, what I'm interested in is the configuration for the ingress gateway. So let's look at the proxy configuration for the routes for the ingress gateway. And as you would have expected, we have 2 routes that have been defined by the virtual service. Okay, and this is good because that's what we wanted. But the other thing that we wanted to verify is that the routes in this particular case have not been propagated to other sidecards in the mesh. So here we're looking at the sleep pod, which is, just a regular pod in the mesh. It wasn't specified in the virtual service explicitly. So the virtual service didn't change the configuration for this particular proxy. So with this, we have successfully applied routes to the whole mesh in the first example. And in the second example, we have applied new routes only to a particular sidecar, which is, well, it's not really a sidecar because in the gateway, the only thing you have running is actually the sidecar. So this is how you can control how your Istio configuration gets propagated throughout the mesh. Okay, so in this video we have seen how Istio configuration gets translated into Envoy configuration. In particular, we have seen how creating a virtual service as part of the Istio configuration is going to alter the routes of the Envoy sidecards. And when we create a destination rule, it is going to change the clusters and the endpoints that are defined in the sidecards. With this, we can have much finer control over how the Envoy proxy does the routing, and this is one of the key pieces in how the mesh is built and how we can do, routing and a bunch of really exciting stuff. We've also taken a look at how the policy is propagated throughout the mesh. By default, normally configuration is propagated across the whole mesh by default, but we can limit this to individual proxies using the gateways command, for example, in the virtual service. And we can also limit this to certain namespaces using the export to attribute. So, there's other ways in which we can limit a little bit the propagation to make sure that only the right sidecards or the right proxies are getting the configuration that we're defining. So thank you. And in the next video, we're going to be talking a little bit about authentication and authorization within Istio. Hopefully you have enjoyed this video. Thanks for watching. Don't forget to subscribe. And if you want to follow me on Twitter, here's my handle. Thank you.